Lesson 7 homework on piecewise functions. We want to be able to graph two or more equations on the same graph, but only parts of them based on what they tell us in the equation. So we'll start with the first one by graph the following set below. So it's h of x equals 2x plus 1 when x is less than or equal to negative 1, and 2 minus x squared when x is greater than negative 1. So we need to be able to graph the two different equations, but only the points that they tell us. So it says 2x plus 1 when x is less than or equal to negative 1. That means we can only graph x values less than or equal to negative 1. So we want to set up our table knowing that negative 1 is the biggest point we can graph, and then we are going to graph as many points as we can fit less than that. So we use our calculator here and we go y equals, and we'll plug in 2x plus 1. We'll hit second graph and go to our table. And if we look at the points that we have, we notice negative 6, we get negative 11. So that's not going to fit in our graph, which is fine. We have negative 5, negative 9. Oops, not negative 5. We have negative 5, negative 9. Negative 4, negative 7. Negative 3, negative 5. Negative 2, negative 3. And negative 1, negative 1. Now, all of these points are going to have closed circles on them because this one had the or equal to sign in its description. So we're going to graph all those points. We get negative 1, negative 1, negative 2, negative 3, negative 3, negative 5, negative 4, negative 7, negative 5, negative 9. And again, we could graph more except for the fact that we run out of graph. So therefore, we are going to draw an arrow pointing down because we could graph more points if we had more space, but since we don't, those are the only points we can graph. So now I'm going to switch colors. I'm going to go to green for 2 minus x squared when x is greater than negative 1. So now we want to set up our table, but we're only going to graph the points that are greater than negative 1. So negative 1, 0, 1, 2, 3. And we'll see if we have any more points that fit when we go into our calculator and graph this. Now, before we get started, because this part only has a greater than sign, we are going to have an open circle at negative 1. Every other point on this graph will be closed, but because it says x is greater than negative 1 and does not have the or equal to piece, we are going to have an open circle at that point only. So now I'm going to put 2 minus x squared into our calculator, into y equals. I'll hit second graph to get back to my table. And now I'm just going to look at the points from negative 1 and greater. So I got negative 1, positive 1, 0, 2, 1, 1, 2, negative 2, and 3, negative 7. And those are actually the only points that fit. So negative 1, we have positive 1. So there's our open circle. 0, 2, 1, 1, 2, negative 2, and then 3, negative 7. And again, just like in the previous one, we stopped there because those are the only points that fit on our graph. But since if we had a bigger graph, we could graph more points, we're going to put an arrow on that side of our parabola. And there's our piecewise function for number 1. For number 2, we're going to set up the same thing. The only difference is we should notice here that we have two distinct stopping points for both equations. So there should be no arrows on this graph at all. So for x squared, it tells us exactly how to set up our table. It wants us to go from negative 3 to 1. So negative 3, negative 2, negative 1, 0, and 1. And notice the 1 part does not have an or equal to sign. So we are going to have an open circle at the 1 on our x squared table. So we put an x squared into our calculator, y equals Second graph gets us to our table, and we end up with these points, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, and 1, 1. So, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, and then the open circle at 1, 1. And again, it was very specific that we start and stop at negative 3 and 1. So therefore, we are going to have no arrows on this graph. So I'm just going to label here open circle. And then if you notice for 2x minus 7, the 1 has the or equal to sign. So that's going to be our closed circle. So 2x minus 7. We'll set up our table, and just like the other one, it was very specific. 1, 2, 3, 4, 5, 6, 7. We should have no arrows on this graph either, and those are the very specific x values that we should graph. So we're going to plug that into our calculator just like we did in the last one. We're going to go to our table, and we should have 1, negative 5, negative 2, or 2, negative 3, 3, negative 1, 4, 1, 5, 3, 6, 5, and 7, 7. So all of these points are going to have closed circles. So we have 1, 2, 3, 4, 5, 2, negative 3, 3, negative 1, 4, 1, 5, 3, 6, 5, and 7, 7. All right, so we'll connect all those points, but we are not going to use any arrows on this graph. So we want to make sure too, and actually I really should go back to the first one here and label. This was h of x equals 2x plus 1, and this was h of x equals 2 minus x squared. So as we start to put multiple graphs at the same time, we want to make sure we label which ones are which. So now that they're labeled, there are two questions on the bottom. State an interval over which f is increasing. So there's two intervals. There's the little red one here, or the entirety of the green line is increasing. So for ease purposes, I'm going, since they already told me what to do for the green one, we're going to have 1 less than or equal to x less than or equal to 7, or 1 comma 7 for our increasing piece. You could also have 0 to 1 for our red part of our graph, but I just took the increasing piece that came from the green part. Then we want to state an interval over which f is decreasing. Well, there's only one area for that, and that is the beginning part of our parabola. So it starts to decrease at when x is negative 3, I believe, yes, less than x, and it stops decreasing when x is 0. So parenthesis negative 3, comma 0, close parentheses. So that's how you graph piecewise functions and get some of our information pieces from each of them.